Here we go. Day 3 of 2025. The largest possible joltage each bank can produce. So the largest two. Interesting. So if our sample is like this, it wants us to find the largest number from left to right that we can make, I think. So it's actually kind of like yesterday's where we need a moving window, essentially. So find the largest number left to right that's 2 digits in a single line. So best way to do this is probably to go character by character, find the largest number, save that as kind of digit 1. Largest first. It's going to equal 0. If for character in line, if character is greater than or equal to the largest first, then the largest first is going to equal the character. And then at the end of it, let's just see if we find the largest. Strings and ints, why is that? Oh yeah, sure. Integer. So we find 9 immediately, and we find 89, and we find 70. There's only one 7 in here because it's second to last. 78, and then 90. Okay, so that looks first, or that looks correct. Then we need to find the second largest. And we also want to probably have the index of that. So for I in enumerate line, so then we want basically everything from index is going to equal I think is what we want. Oh, we can't use that. Index of I. Dumb. Naming things is hard in this challenge. The 0 index. The 14th index. Sure. The 9. Yeah, I mean, this looks correct. So then what we're going to do is do another for loop for the second we can say largest second is going to equal 0. So for the rest of the numbers, basically, from that point forward, so for y character in enumerate line, we're going to do it again. If the integer of character is greater largest second, and the largest second is going to equal that, like we did the first time. But what we need to change is for an enumerate line of index I to the end. Index I to the end. And then what we'll do is we will print the largest first and the largest second, and hopefully 99. That didn't quite work. Now did it? Why is that? We get 99998899. Yeah, that didn't quite work out. There's no second 9 in here, so I'm not sure where it's grabbing the extra 9 for, or where it's grabbing it from. Let's try that. Nine eight seven six 543211111. So it, I mean, well, because that one starts at the beginning, and that one starts at the beginning. Do I need +1 here? Nope. What have we done wrong? We basically need this on the second for loop to skip number 9. And I don't even think we need the enumerate here. So let's just remove that. Though for debugging, that might have been nice. It's never going in there. Oh, it is going in there. Do I need to break out of? Yeah, okay. So we're going to do that. That gets us 78 on that side. And then similarly, if we had the other problem child was this second one, it doesn't know what to do, I think, because this one starts and then this one at the very end. So we need to have a second thing just like that, I think. So ensure end digits are the bookends. So pretty much this same block tweaked slightly. So if the last one equals the character, in this case 9, and the character is equal to or greater than the largest, then break. Oh, that's not right. So let's print the line. The last one, it should be a 9. Oh, we're not printing anything. Why? Oh, because what we do is, well, no. We set the largest to 8. Well, okay. It goes all the way through. It hits 9, realizes that, hey, we can't go to the next one. So it counts that as the biggest. Okay, this is dumb, but a cheap way to, if we get to the end, don't accept the final character as largest, since we don't have a second. There are a lot of ways to do this. For time, I'm just going to do that. That gets us our 89, which we're after. So now if we put this all back together, do we get the proper... Let's get rid of some of these prints here. Okay, we get a 98 check, we get an 89 check, we get a 78 check, and we get a 92 check. So if we then throw in the actual input for the day, we get a bunch of numbers. What is the total output if you add them all together? So let's keep, well, it wants the totals, going to equal 0. We're going to then do total plus equals the largest for, wow. I can type largest first plus the largest second. And then, you got to return that. That's usually a good thing to do. And then you usually got to print that. 13. That's not right at all, because those have to be one number. So we will integerize this, and then we will f-string this, and then we will, nope. What do I want? No, yeah. Right? 76. Still seems incredibly low. I need to basically put them back together. Oh, that's not right. Am I? Huh? There we go. Just for fun, let's put the sample back in. It should give us 357. Okay. Now if we do that, we get 13403. Let's try it. It's not the right answer. Are there any crazy things in here? Nope. Okay. I guess let's print debug this. Oh, see, some of these have, because I'm double printing. So like the last line, 75. We got a 7 in the front. Nothing else is bigger. $76 on the top. 7 and a 6. It's going to be hard to know what the problem is. Let's reread real quick. So we can't rearrange them. The largest possible each bank can produce, just going left to right, is the sum of the maximum from each bank. Okay, well, the second to last line is 2, 3. Oh, and there's a 9 in there. So yeah, definitely something's wrong. Just for fun, let's get rid of all this and see this really interesting one. What comes of it? It gets 2, 3. Which is crazy because, yeah, there's like 9 in here. 7, 5, 4. Lots of stuff that's over that. So the last one in the line is a 3, which is correct. So, I mean, it's getting that. It gets to a certain point and then it breaks. Oh, hey. Yeah, these are really long. I see. And so it's got duplicates. And so it's breaking here. If the character equals the second to last number, so let's just focus on this. We get to yeah, it definitely breaks early. Also, it doesn't start at 2. Oh, because we're just printing the second half of it. So yeah, we interesting. Oh, yep. We should not have these right there. 7, 7. We had a greater than or equal to, so it actually bumped it to the next one. Let's put this back to sample. We should have 357, and then if we put this in input and we try it again, 17. This feels correct, hopefully. All right. So the joltages are much larger. The largest joltage can be found by turning on everything except ones at the end. Sequence, the largest joltage can be found by turning on everything except some ones. What? Oh, 12 digits. I see. So what's the largest 12-digit number you can create? All right, I think I'm going to call it there. For the evening, I think I'm very close, but I didn't account for a couple edge cases here. So part 2, basically, it makes me wonder if an option would be recursion as I have, but with a back off strategy. So for instance, I implemented something like this in a Sudoku solver that I did. And if it tries to solve it and it doesn't get the correct answer by going, all the way across, all the way down, and then in the quadrant, as it normally is, it will backtrack and attempt another solution. So I'm curious if maybe that would have been the play here. But I don't have the time or care to attempt to implement that. So I think we're going to call it here, but I think that that would have done it. Basically, here, right, we go all the way down. We find that 8 is the best answer, but we can't make 12 digits. So then we go backwards and we get 7, 8, but that's not 12. So we go back 2, 7, 8. Okay, that's big. 4, 2, 7, 8, etc. In fact, that actually would work really well. So I might come back and redo it again, where we basically say, and then right here, we say 2, 3, 4 is that the biggest? Go back 1. No, 4, 3, 4 is the biggest. So I think I know how to solve this. I don't want to spend the time to solve this at this point, but I think that's how I would actually do it, is attempt to go backwards if we couldn't find the answer, try the next solution until we get the true largest number, and then we would be good to go. So I think it was close. Part 1 was correct, though. I'm going to leave this recursion in here in case I want to come back. So hope you enjoyed.